Moving along, we will look at a bit tweaking of the formula, right? Still on the derivative or the differential of a function, right? The derivative of a function f is a function denoted by f prime, which is defined by. So any given function, right? Say f, okay, is the functional or is the function denoted with by f prime. It's simply telling you that when you have a function which is given to you, say f of x is equal to x squared, right? Say f of x is equal to x squared. Then to find the differential of that function, f of x is equal to x squared, we would say f prime of x. That means you are differentiating, or that means you are finding the differential of f of x, right? So we say f prime of x is equal to 2x. So if you differentiate x squared, you get 2x. That's what I'm trying to say, okay? Provided the limit exists. So we would say that the limit as z approaches a is now being changed to x, right? Why? Because the question given to you will be given to you in terms of x. Say f of x is equal to x squared. The function is given in terms of x. So we are just changing the values of a to x in the formula. So limits as z approaches x. We say f of z minus f of x. Remember, it was f of a in the initial slide. It was f of a here, right? And then because the function will be given in terms of x, we'll say it's being changed to f of x, right? So all over what z minus a is now z minus x, right? So the final formula is saying that to find the differential of a function using the first principle, then as the limits h is approaching what? 0. Limits h approaching 0. F into brackets x plus h. Okay, remember we said z is equal to what? A plus h over here, which was found just making the change of subject here, making z the subject from this term or this function over here. We had z to be equal to a plus h. And because the term will be given, the function will be given in terms of x, we would say that we are going to just change this a to be x, or we're going to replace this a with x. So therefore, we will have f into bracket x plus h, which is the same as z, right? Minus f of x all over h. Remember that z to x is equal to h, which is our horizontal distance. Remember, h is our horizontal distance. It's equal to f prime of x. So the final formula for differentiation from first principle, or finding the derivative of a function using the first principle, is that f prime of x, simply telling you that we are differentiating, f prime of x is equal to the limits as h approaches 0, right? As h approaches 0, f into bracket x plus h, right? F into brackets x plus h minus f of x all over your h, which is your horizontal distance, provided the limits exist, right? So if the limits exist, that is fine. That is maybe x is approaching 2 or x approaching 7, x approaching 5. But here, the limit doesn't really exist, right? So we'd say that h is approaching what? 0. Okay. So if f prime of a or f prime of what? X can be found, the original function f is said to be the differential at a. So if you have a function, say f, the differential of this f function is said to be f prime of a. If you are given a function, say f of a or f into brackets a, the differential of that function f of a is f prime of a. Okay, and f prime of a is called the derivative of f at a, right? So if you have f of a or f into brackets a, f prime of a is called the derivative of f at a, or the derivative of f with respect to x at a. Note, the process of finding the derivative of a function is called the process of finding the derivative of a function, right? The function is called differentiation, right? Right. So looking here, we have a basic example under differentiation where we can use the first principle to find the differential of that function. So if f of x is equal to x squared, we've been asked to what? Find the derivative of f, or find f prime of x, right? We'll say find f prime of x. Okay. We asked to find f prime of x if the function notation of x is equal to x squared. So here we would use the first principle formula, right? We use the first principle formula, which is saying that to find the derivative of a function, it is f prime of x, simply telling you that we are differentiating. So f prime of x is equal to the limit of that function as h, limit of the function as h approaches what? 0. F into bracket x plus h minus your f of x all over h, which is your horizontal distance. Okay. So I'll take you through this whole f into bracket x plus h minus f of x all over h, right? This f prime of x here simply means that you are differentiating. Okay, and the limit is that h is approaching what? 0. Okay, so I'll take you through it one after the other. We have the numerator f into brackets x plus h. What does it mean? The f you are seeing here, right, represents the coefficient of the function you are being given, or the function you have. What is the coefficient of x squared? We all know that the coefficient of x squared is 1, isn't it? So f here is 1, right? So that means it is 1 over here, isn't it? The x plus h is just the summation of your horizontal distance plus x. Okay, why is it x plus h? You always, this x plus h over here is constant when the function given to you here has a component of x, or the variable x in it. We can see that we have x squared here, so this function has a component of x. So we'll say 1 into bracket x plus h. Note that 1 into bracket x plus h. The x plus h is constant. You write the x plus h when the term given to you has a component of the variable x. Right. So it is 1 into bracket x plus h. But is the term raised to any power? Do you have any power on top of that variable you have over there? Yes. This x over here is being raised to the power 2. So I would say 1 into bracket x plus h, right, minus f of x. What is f of x? F of x is the same as the question itself, because it says f of x is equal to x squared. So I would say 1 into bracket x plus h all squared, because the function is raised to the power 2, minus x squared, right? So you can see it here as a limit as h approaches 0. So 1 times x plus h all squared is still x plus h all squared, right? So that would be x plus h all squared minus your f of x, which is what? X squared, all over your horizontal distance, right? So moving along, we would see that we would have to expand. The next thing is that you just expand what you have here, because you're having x plus h all squared. It means you're going to multiply x plus h by x plus h. And then when you expand that, you group like terms, right? You have x squared plus 2xh plus h squared. This over here, right? This term over here, x squared plus 2xh plus h squared, is the expansion of x plus h all squared. If you expand this function over here, right, you would get x squared plus 2xh plus h squared, then minus your what? X squared. Okay, what is the next thing? We would still write f prime of x is equal to the limit as h approaches 0 Then we can see that we have positive x squared here, we have negative x squared here. So this positive x squared will cancel this negative x squared off, leaving us with what? 2xh plus h squared all over our h, right? The next step is that looking at this numerator over here, 2xh plus h squared, it has a common factor, which is our h. So just do basic factorization. We'll factor h out, still having your f prime of x is equal to the limit as h approaches 0. We'll factor our h out, leaving us with 2x for the first term plus leaving us with the h for the second term. Simply telling us that if you multiply h by 2x, we get 2xh. If you multiply this h over here by h, you get the h squared all over your h, right? So this h here, right, can do some cancellation here, right? We can cancel this h and this h. This h and this h will go off, right? Leaving us with what? The limit as h approaches 0, 2x plus h, right? 2x plus h. The next thing is that you are done with the factorization. You've been able to do some cancellations here with the h, right? Numerator cancels the denominator. You are left with this. Now you are saying that the limit is that h is approaching 0. Simply telling us that when you get to this particular point, the basic idea is that when you get to this particular point where you are done with cancellation of some of the terms which are like doing your factorization and then getting the final term, what you do is that you substitute 0 in place of h. It simply means that wherever you see h is approaching 0. So wherever you see h, you just put the 0 over there. So that will be our f prime, right? I could say our f prime, right? Our f prime of x, okay, is equal to what? 2x. Or we can also see that our f prime of x is equal to what? 2x. What does it tell us? It's telling us that the differential of this function, or to find the derivative of the function x squared, it is equal to 2x. Or the differential of the function x squared is equal to what? 2x. So take note, you can see that this is the function notation, or just the function. It says x squared. When you are differentiating, we would say f prime of x is equal to 2x. Okay. These are some common notations of a derivative of a function. It's simply telling us that, or it means that if you have a function, say y is equal to, say y, right? Say y is equal to x to the power 2, right? Say x squared, say x squared, right? You have a function, say so let's say we have a function, say y equals, say y equals y equals x to the second, right? If you have a function, say y is equal to x squared, like what you have here, it could be f into brackets x, or f of x, right, is equal to x squared. It can also be given to you as y is equal to x squared. It is the same. That's why initially you would have y is equal to f of x here in the diagram, right? Y is equal to f of x. The function can be given to you in terms of y. Say y is equal to x squared. It can also be given to you, say f of x is equal to x squared. They are the same. Right? That's why y is equal to f of x. So if it's given to you like this, then I would say to find a differential, we're not going to write f prime of x because we have y here. It's not f of x. So to differentiate that, we would say dy over dx. Okay. To differentiate this function, we say dy over dx Okay, we'll say dy over dx is equal to what? 2x. This is the shortcut. Right? So instead of writing f of x, or instead of writing f of x here is equal to x squared over here, it's the same as y is equal to x squared. But if it's given to you f into brackets x, or f of x is equal to x squared, then the differential of this would be f prime of x is equal to 2x. But if the term is given to you, say y is equal to x squared, then we would say dy over dx. It simply means that the derivative of y, or the differential of y with respect to x, or the change in y with respect to x is equal to 2x. Right? So these dy over dx, these common notations, dy over dx, dfx over dx, y prime, dxy, dx, f of x, they are all the same as finding the differential of the function, right? F prime dy over dx depends on what you have here. So if it is y dy over dx, if it is f of x, we would say f prime of x. Okay.